Ready?
Nope. Intros suck.
Intros suck. Okay, this is ScannerDanner. He's at my shop because I had a video that I had a question about. He does more technical stuff than me as far as deeper into waveforms, and I admitted on mine that I wasn't sure with everything. So, you know, as he came to actually drop off the tripod that is holding that camera, I started talking to him about it, and he was like, "Oh yeah, I just pretended I watched it," and said, "Good content, whatever, doesn't matter." But I started showing him, and he was like, "Hey, I actually have a case study on that." So it turned into that, and he's like, "We should film this," just because I had a lot of feedback with people, you know, theorizing, talking about what could be happening in the circuit, and I wasn't sure. So that's now why we're here.
Cool. And for those of you that don't know, this is my brother Jim. He goes by Danner. We've called him Danner forever. And I did a little intro video. You guys can check it out. It's on my channel somewhere. I'll put a link to the Danner video where we started. But for those of you that don't know, he's filming repair videos on YouTube as well, and his channel name is James Danner, which was weird. Nobody calls you James, but except people in YouTube land.
I tried to pick a nickname. I don't know what happened. It just wouldn't let me. I had to put my real name in, and that's what happened.
So James Danner, check out his channel. I'll put a link in the description of this video so you guys can go over to his channel and see what he's doing. And for a lot of you guys that want more repair videos, and I've been dropping the ball on my free channel, I've been so busy, you can fill in the gaps with this guy because he absolutely knows what he's doing, and you guys need to be part of his channel. So make sure you guys go do that. So what we're doing, as he said, is we're talking about a video that he recently did, and it's on a Toyota Avalon, and the title of the video, and I'll put a description in the video as well for this one. The title of the video is Toyota Avalon Misfire Repair, and you guys would do yourself a service to really pause this video right now and go watch his video first and think about the questions that he asks you in the video, and then come back over here and watch what we do in discussing what we found and really answer those questions. I just think that it'll challenge you and allow you to really think on your own first before you come back and watch this. So just a suggestion, and for those of you that have already seen it, you guys are definitely going to like what we're doing here. And this is in particular, I'm talking to his viewers who've already been debating this and watching it. So Toyota Avalon Misfire case study. Let me pull you up on my screen over here. Okay, so the title of this, as you can see on here, it's the Toyota Avalon 3-liter Misfire. That's his title. And let's take a look at the engine. It is a V6, the 3.0, 24 valve. And there you see his channel name there. And next slide that I got is when he was reading the fault codes. He had a random misfire and then multiple cylinder misfires. And then he also had a lean exhaust. And so I guess my first question to you would be, how do you attack that? Where do you start?
Well, actually, I went into the on the data stream side. There was a misfire monitor. Luckily, some cars don't have them, or they'll just say yes or no. And you know, like the Fords, you got to go into cylinder contribution. The Toyota on the Solus actually gave me the option to see what was misfiring. So I never chased 4 or 6 because they weren't happening, and they're not even on the same bank. They're on a different bank as well. So I mean, that one may creep up in the future, but I stopped at. You know, so I saw the misfire. If you go to, I don't know if you pulled that up and you put that on your screen.
I did. I have it.
When I had the misfire, you know, that's whenever I was hoping that they kind of, you know, were linked together. And I know, you know, if you have a misfire, you have extra oxygen anyway. You know what I mean? Even if you have tons of fuel, say it wasn't.
So is that where you're going with this lean? The lean code?
Yeah, I mean, I wasn't sure whether it was a fuel or spark issue. You know what I mean? In theory, if you have a no spark scenario and there's, you know, fuel and air, the oxygen sensor is going to read the air because it never burned anything. So I mean, I looked at that and I was hoping to correlate my misfire to that lean and fix 2 things. And I didn't know, do I have a vacuum leak? You know what I mean? Or was it spark? Was it fuel? So
is it safe to say that you felt a consistent misfire too? You went by senses too.
Oh,
you
yeah.
felt a dead miss. And So that would make sense that you pulled up your misfire monitors or your misfire data because you felt a consistent misfire and you're trying to figure out which cylinder it was. And hey, multiple codes, let's start somewhere instead of being wishy-washy and going all over the place. Yep. All right, and then I just took a couple of shots here in your video, and there's 48 counts and 90 counts, and so the definitely number one cylinder misfire, and then you started focusing on the number one. Spark fuel compression is your thoughts, right?
Yep.
And probably like me, what is the next easiest step? I mean, that's really...
For me, I think the next step I did was just switch coils and plug.
You did.
Because I could get the number one easily.
Yep.
And I've run into that. I mean, I had that Pacifica where I had that misfire and it ended up being a frayed wire somewhere. And, you know, I just did, you know, you're in a shop, you know what I mean? You get, how many Fords have you got, you know, where it just misfires and the coil's bad and needs a plug in a coil, you know, so I've, you know, got bit by that replacing stuff and like, you know, there's something, you know what I mean? Because you're in the shop, I'm in the shop trying to get stuff done, you know, and sometimes you don't spend the time. So I swapped two just because it was easy. It was kind of easy to get to number one. So.
Yeah, well, as I was watching this, I'm like, it figures the number one in its location.
Yeah.
That's not a great still shot of that, but the number one's under the intake manifold.
But I was able to get to it.
I know, and it can't be the front one. And I see you know, you swapped it with the front one. It didn't change. You stayed with the number one, and I really liked your RPM drop test right here, where I teach the RPM drop test all the time, and I get questions like, well, how do you do it? Which way? There isn't one way to do it, and that's a really nice one you showed. We just needed to let our viewers know that there's the risk of just getting shocked, and it won't kill you, but you know, maybe if you had a pacemaker or something. Yeah. We have a friend, his name's Pete. Actually, you guys know him, Latour's Auto. He's got a pacemaker, and we got to keep him away from
maybe he won't
stuff like that. Yeah, but
so that's called an RPM drop test. I just listen for the arc, you know.
Well, no, but when you were doing it too, I think you were showing your viewers the misfire counter on the scan tool, but you were also showing the RPM change. I don't know if that's what you were stressing, or maybe I missed that.
No,
part.
I wasn't stressing it. I was actually, I heard
you knew
the arc.
It was your number one.
That one's number two.
I know, but I'm saying when you did you were showing that for what main purpose then?
Because I wanted to say that in the shop, for me, you know, without breaking out lab scopes and stuff, first thing I'm doing is, if I can do it, I pull a wire off and listen for an arc.
Oh, gotcha.
You know, because this actually, see how that's clean? That one is the one that was on number one.
So it looks like somebody changed that before?
No.
Oh.
No, that was just, there was no duskets under the intake.
I got you.
You know what I mean? So that's the actual one that was in number one when I swapped them, and my misfire stayed in number one.
Okay.
And then like I said, I just pulled it out to make sure it arced.
I understand.
And then the same thing on the back, if I didn't show it because it's hard to get to, like you saw, but if I pulled out number one, it also would arc, but the misfire was there, so the RPM didn't change, but I could hear the crack of arc.
I understand. See, I misinterpreted that. I thought you were showing the RPM drop test to make sure that it was, in fact, the number one that was misfiring. I think, and we know that, we both know this, the viewers know this from watching what we're doing, is you can have many vehicles, especially with a P0300 code, that it's saying number one, and even number one's counting on the scan tool. It doesn't really necessarily mean it's the number one, so we need to be careful with that. But that's what I thought you were showing there, is that part. So no, that's good. You're listening for an arc, and that coil fires. You know that's a good coil, and we're moving on to the next step.
Yeah, and I actually think I showed the misfire counters on number two start climbing when I pulled that.
You did, and I think I have that. You did show that, and I didn't capture that. When you pulled that, you showed the number two misfiring, which gives us confidence to believe the misfire counters that we're seeing. Yeah. So I like that. Next one, I kind of like this one, because you had mentioned the clicking and that you were listening to the injectors, and this is for our viewers. I'm not questioning him this, but clicking, a lot of people think, well, it's clicking, so it's good. Clicking does not mean it's good. Just a little.
Yeah, but I mean, if I don't hear a click, then I'm, I'm looking for an open injector, broken wire, a circuit on a computer not grounding it. But when I heard the click, my next step was like, well, first it was like, do I want to pull that plug back out and do a compression test in that cylinder, because I know it's in that cylinder, or do I want to do the pressure test with a fuel pressure and see if it drops? Maybe it's clicking, but it's clogged.
Yeah, right.
You know what I mean? So that was where I
That's
started
coming
going.
up, what we're doing next. So I like the clicking test, for you guys too. We want to be careful that noises transfer, especially with a stethoscope. And just because you hear clicking on that number one, it could be the injector next to it that you hear So make sure you compare the two.
Can I raise my hand?
Yes. Yes.
I actually unplugged the injector while I was listening to it, and I
Nice.
heard it.
That's a good test.
Click, no click, click, no
So
click.
that's a good test.
I knew it was clicking, but I didn't know if it was clogged. And
Cool.
with the system lean and everything, I was bouncing between
See,
two.
I don't do it that way, and that's the cool thing about this field is there's more than one way to do things. And I never even thought about unplugging the injector while you're listening to it. Duh, that makes perfect sense. I've always taught my students to listen to the one next to it and then compare.
Yeah. Well, you do that too.
Yeah, no,
Yeah.
that's a great suggestion. All right, moving on. So now you have a test light connected to the injector. This is the point where, and for you guys that are following along, this is at 6:31 in the video.
This is where all the questions start coming up.
And so you have a test light connected to the injector, and I understand why you're doing it. You were looking for control. Which one was control? Because he was going to do a balance test, and that's where we were going with this. And my first thing before we continue is test light's connected to ground. And I just wanted to make a point that we need to be careful doing this because depending on the resistance of your test light bulb, you may actually energize the injector, not even partially, but fully, and there's fuel spraying constantly. We just need to be careful about that. So
I had a guy actually respond. One of my first responses was that happened to him on a Ford, and he generated a whole rich bank
yeah,
doing it. You know what I mean? But it was like you're in the shop, you're doing it real quick. I already had a back probe looking for whatever, and I was just gonna see which one had power and unplug it. And when you unplug it, if the power goes away, then I'm on the control side. Then I knew which one without going to a wiring diagram.
yeah,
just
right.
trying to go real quick.
That's coming up. I'm going to ask you about that. So hold that thought. Hold on. All right. So that's where we are, and so I never even thought about doing it this way. And again, this is the nice thing about this field when you get into the mind of another person, and you learn different techniques, and that's really why I value having my brother here doing this with me. Is his approach is different than mine, and neither one of them are wrong. And for those of you out there that think, well, you need to do it this way, well, no, there's so many different ways to do things, and it's a good. So that's where we are with this.
Yeah.
This test is he has connected to the injector, and in the next shot he simply unplugged the injector. So I'm going to be the student. You answer my question.
Okay.
What does that mean? When you unplug the injector and that light went out, and he's connected to ground, so we need to be clear about that. The test light's connected to ground, and when the injector plugged in, the light is lit, and with the injector unplugged, the light is not lit. Before you answer why that happened, what's the reason we're doing this first? Why are we unplugging the injector by looking at the test light?
The reason I was doing it is because I wanted to be able to ground the injector separate from the PCM, just to generate a injector pulse and see if, with it instrumented, I had a fuel pressure gauge on, which I didn't
Back
show.
up. You're missing a step. You were identifying the control wire first.
Oh, yeah. Well,
So
that's what I was doing.
The reason we're
Yeah.
doing this step, so his intent was to, what he just said, to ground an injector individually by himself. But before he could do that, he needed to know which one the control wire was.
Yeah.
So that's where we are
Yeah.
here. And so by the light going out, when you disconnected it, that tells us what?
That tells us that I am on the control side.
What
So
would that have done if that was on the feed wire?
It would have stayed lit.
Okay, so that's
Or if it stayed lit and I had a short the other way, power that way. But I was looking for that to happen.
Is there a variable to that test? And I'm thinking of the GM multi-port systems where they're group fired, and we unplug one injector and try to use this test to identify the control wire.
I guess if they're in series
or parallel.
Parallel, yeah.
Guys, this only works on a sequential engine. We can't do this control identification on a group fire. Now, those are older systems, and they're all, well, here in PA, they're all rusted out and pretty much gone. But that's a good test, but
Yeah.
we need to make sure people know that that's for sequential
Sure, yeah. If they're
only, because
Yeah.
that'll be misleading. You unplug the injector, that light's
Yeah.
going to stay lit on both wires. And anyway,
Yeah, and if you look at it, yeah, exactly. And if
Yeah.
you look at a wiring diagram, you'll see a junction point somewhere. You know what I mean? And,
Yeah.
and they're all different colors. And you could look and see, okay, I have 6 of them are all one color, and the other, 6, one for each injector, are all different color, different tracers. So those are usually the control sides. But I
Right.
mean, from a quick just
Yeah.
real quick. And that I would have caught this if I wasn't just trying to zip through it. You know what I mean?
Yeah. No, that's a
So-
great. I like that. I didn't even think about using that to identify control wires. Unplug it, look for the light to go
just
out.
look for light to go
Oh,
out.
that's a good
and
test.
Yeah, and then it tells me the same thing with it plugged in. The circuit integrity of the injector is also good if I'm seeing power through it. You know what I
Correct.
mean?
Yeah, for
as
sure.
well. So I mean, it tells you a few things.
Yeah.
You know, just on a real quick, scale.
I like the test.
So.
All right, and so let me. Okay, and I thought that your intent here was because you were going to do an injector balance and you were going to control that control wire, and that is correct,
Yes.
right? But you weren't going to use a timer tool. You were just
No.
going to
Just see if it works.
ground that
period.
injector and put a fuel pressure gauge. Okay, I got it. I was unclear about that part. So he's putting a fuel pressure gauge on the car, and he was going to manually ground that injector and see if he had a pressure drop, and that'd be with the car off, pump not running,
Yeah.
and that's a
And I'm not going to hold it on. I don't want to flood the cylinder.
guys,
out
this
either.
would be momentary, and
That's
this
it.
would not be something
That's
you'd
all.
want to do on every injector design either. I'm thinking of GDI systems. We're not doing that on a GDI. And then some of the older peak and hold injectors that you could actually overheat an injector coil. No worries with this saturated switch design. So, sorry, that's big words there.
That's
but-
all theory stuff. That's
Yeah.
why you're the teacher and
Okay.
I'm out here doing it.
All right, so the next one, what you had mentioned, the car was running. You mentioned a flicker in the video, and the misfire went away at this point. We have the test light connected.
Yeah.
Couldn't see the flicker
No, you couldn't.
in the video. Just thought I'd mention that we definitely heard, though, the misfire go away, and I think in the next shot, yeah, this is kind of, can't really see this on my desktop here. I don't know if I can zoom in on that. All right, so you can see the misfire is gone when you had your test light connected, and this is where a lot of our debate has come from. And I understand, absolutely understand why. And I haven't read any of the comments. I'm sure that we should be giving some people some props for
Yeah.
getting things right, but we'll continue through this. So at this point, what I paused it and took this still is you're disconnecting the test light from the injector, and then we're showing the. Why did I show that image?
I think I was just showing the misfire return.
Misfire return. That's right. That's why I'm missing an image in there. So clearly the test light's doing something.
Yeah.
Next capture, we're showing the waveform of the bad injector and that goofy looking.
That's the brick. Yeah, no, I like I said, I'm just doing it. I'm just
Oh,
trying
no.
to do it quick. And you're like, why are you using that tool when you have the other one? I went, just, I don't even have a regular.
See, here's the thing. He was thinking of you guys and trying to give you a tool that can be bought for literally a few $100s off of eBay and do a lot of the stuff that we're doing. And me and the institute that I teach at, we have all these thousands and thousands of dollars of tools, and everybody gets on me about that.
Oh, but that's awesome though. You know what I
It
mean?
is, but it is nice that you're showing a method here that these guys can go out.
It can be done.
On eBay and buy a Vantage, an older Vantage MT 2400 and get an injector waveform pattern.
I use it for a regular voltmeter.
Yeah, me
when my
too.
furnace crashes at home or something
I'm
like
the
that.
same way,
I don't even have a regular DVOM, I don't think.
Agreed. I was just doing wiring at home with my Vantage in my hand.
That's right.
Exactly. So pretty goofy looking pintle hump there that you guys were talking, or you were talking about in your video, and then we're coming up on the, I think, meat and potatoes here, guys, of what was going on. Let me just get my bearings here. There's a better shot of it. And then I show where you're showing a good injector.
That's the one that was firing.
Right. So that's a good injector, and this is the misfiring injector, and then the next image is him connecting his test light back up to that injector while we're monitoring the voltage pattern, and we get this goofy looking pattern now, and our misfire's gone. And so this is where I wanted to start talking about
That's cool.
what and actually, to be fair, we talked about this before filming, so this isn't me teaching him. This is both of us putting our heads together and saying, oh, that makes sense.
But he was like, I had a case study on this and it's in my book.
Well, okay.
That's cool though, because people were talking about it and that's why we're here.
Well, that is true. And I'll just show you the one slide. I pulled it up already. This is actually in my textbook that I use in my class. And don't look.
It's the same.
Don't look at any of the numbers yet, guys. I just want you to look at that waveform right there, and you know, it looks well, it looks a little bit different there, but I'll tell you what, your current ramp pattern looked a lot like that.
Yep. And is this the good one here?
Yeah, that's the good one. And we'll talk about these flow numbers here in a
Sure.
minute. So, but you're right. I do have this in my book, but that was not the intent, is to plug my book. Although I do plug it every chance I
Yeah,
get.
why? That's I just thought I did that for
Okay,
you.
you did. Thank you for that. Okay, so first thing is we need to talk just a little bit about the injector itself. So when that injector, and let me get a little ink in here and just make sure that our viewers understand what we're doing here. Let me find out where we are. Okay, so a fuel injector, when that injector is turning on, would be at this point over here, the injector's off. This would be injector off right here, and this point from here to here would be our injector on time, or our pulse width. It's ground side switch, so that just means that when we close the circuit to ground, we have current flow, and then at the end of that, we have the spike. And the reason the spike is there is a collapse of a magnetic field. So I want to call out one thing first that I want you guys to look at, and that would be, let's back up a slide. Take a look at the height of the spike on, oh, that's the good injector. Let's go to the, having trouble with my ink. This is my smartboard program without the smartboard. Take a look at the height of the spike on the bad injector without the test light, and take a look at the height of the spike with the test light. So I had mentioned this to you earlier, that I noticed a change in that spike, and I took a couple of captures. So let's just scroll up and down through that. Let's take a look at the captures of the spike. So it is changing. There's times where that spike is good, and there's times where that spike is dropping. And then I did a picture to compare. That was actually the good one. That wasn't a good comparison, because the one to the right is the good injector. If we're going to compare them, let's compare the injector with and without the jumper on there.
But I see what you're saying, where the spike is way below the 50.
And not all the time. In the video, you can see this line is changing. This line's going up and down. And one of the downsides of the older Vantage is the detail in this scope. You're missing some stuff. There's only 100 pixels, and you know, it doesn't have the kind of resolution that your Vantage Pro is going to have. But we can definitely see a change in that. So what I always tell my students is what we're looking at for that is your magnetic field. The height of that spike will be solely determined by magnetic field strength. The stronger your magnet, the heavier, when it collapses, the bigger the spike you get, and that's what you got.
Sure, and if I have a test light with resistance to ground, I'm fooling with that.
Yes, exactly. And I would say it is resistance to ground, but I would reword that and say you have a test light connected to the injector circuit that is maintaining current flow when that injector is turning off, and that magnetic field is not collapsing the same way that it was before. It still is,
I buy it.
But it's not the same. You have current flow through that test light. And I believe...
So I should have had my low current amp probe on the test light winding?
Wait, what?
I should have had my low current amp probe on the test light wire lead to the battery.
You would have shown... Yeah.
We'll do that one next.
Well, look, I think that also explains why your pintle hump is now later and delayed, where previously your pintle hump's right here, which is very pronounced. And by the way, guys, the pintle hump, that's a lot of lingo, and it just has to do with magnetism and iron cores and moving a magnetic field. If you distort a magnetic field or move a magnetic field in any way across the winding, you will induce voltage. So what's happening with a fuel injector is, as it's closing, your iron core is moving through a collapsing magnetic field, and that's where we get this, quote, pintle hump. So where does that pintle hump occur? It always occurs right at the point where that field is collapsing, right there. And that's where you see that very pronounced. And I believe the reason, and I think some of your viewers got this right in talking about the test light affecting current flow, I'm not sure, but I believe the reason that hump is late is because of the magnetic field is being held longer, and it's taking longer to close. Now, you
see the pulse width difference on the...
I do, yeah, for sure. And I mean, that's going to be, and you mentioned that in the video, that's going to be your O2 response to now a richer condition, and it's going to lean it, and computer, that's closed loop reaction right there is what would cause that. But I want you guys to look at something else. And I noticed this as I was editing, or not editing, as I was taking these shots. Take a look at this voltage line right here and where our off time is of this one compared to no jumper wire. It's very subtle. You can barely see it. So compare that line with where we are here. This line to the left is, my guess, is about 1 volt lower than this line is over here. And if you look at your graph, this is 50, up here's 50.
Mm-hmm.
And so this would be 40, this would be 30, this is 20, and 10, and 0, right?
Yep.
So, you know, it's hard to see on a 50 volt scale. It's hard to see a 1 volt change.
I see what you're seeing.
So what
there goes my resolution.
That's right.
Yeah.
What I'm saying is that test light is even affecting the off period of this fuel injector. There is continuous flow through that test light, an alternate path to ground. So to give you guys just a real quick visual, here's what we got. We got battery positive through an injector winding on its way to a transistor that's switching open and closed. This is inside of the engine computer. We have a test light that is connected here to a known good ground, and I just reached the top of my screen there. This is ground. And so what I'm telling you guys is we have current flow all the time that is running through the winding, and it's running through the test light to ground. We still have, why does that look so blurry? That's weird looking. We still have a transistor that's turning on and off as well. So at times current flow is going that way, at other times it's going 2 different directions. One other thing to point out is, and I mentioned this to you earlier, it takes more current to move something, more of a magnetic field to move something than it does to hold something. And if you guys study starters, that's how a starter works. We have 2 windings, a pull-in and a hold-in winding that make the solenoid move, but then as soon as the starter engages, the one collapses, and it still holds it there, even though we've lost half of our magnetic field. So this isn't unprecedented. What we're dealing with is exactly that thing is being held by that test light.
Yeah.
It's still collapsing. It's not enough to hold it indefinitely.
But it slows it down just
and
enough.
this is where I was talking earlier. If you use a different test light here with different resistance, you're going to have completely different results. This is not going to be a standard. It's really going to be bulb resistance. If your bulb was less resistance, this line would have been a lot lower, and that injector would have been spraying all the time, and you would have really been flooding that thing out, is what would have happened. So
or if I used my other test light, it might not have done anything.
Exactly.
You know?
Exactly.
It was just, you know.
Good point. If you guys would be using an LED test light at this point, forget about it. Nothing happens.
Where's it
Nothing
at?
changes.
People hate this thing.
Oh, the test light.
So if you want to, while I'm talking, show the part where, can you find that, or are you still not done talking?
There's more, but go ahead.
I was just going to give
mic's
you an
right here.
opportunity
I am talking
to tell everybody how wrong I was.
It sucks to
and how
how wrong you were about the pintle hump. Oh,
No,
so you're going to put this noise over my
so
voice.
you could go ahead and tell, how
I
I
don't
was
think
wrong.
this is going to make it in my version. It might on that one. I don't know. We'll see. That is a horrible test light.
I know. Everybody hates it, but I like it. It works.
All right, come back here. All right. So next pick. We have the same kind of thing going on with current patterns. This is where our current flow begins. This is where our current flow stops. And that right there is your pintle hump. And it's normal to see that. Again, we are moving an iron core through a magnetic field, and we distort the magnetic field when we do that, and that will induce a small voltage, and that's what makes that hump.
So is that when it's opening?
That is the opening part of the fuel injector, correct.
Okay.
And if you were to superimpose, say, the voltage waveform over top of this, you would have a pattern that would do this, and then our spike would be here, and then you'd have your pintle hump at the end.
At the end.
Technically speaking, that injector is flowing the most fuel from here to here, so it's actually delayed.
Sure. Yep.
There's some of that involved in the engineers and what they decide to do with the injectors and stuff like that. So get rid of some of this. So pintle hump, for those of you that need a little more info on that, of course, I have that info in my material, in my book, and in my premium channel too, where we go through all these injector waveforms. We're not going to do that now, but just a quick note on that. There is no standard for where that hump is going to be. Every injector is different, and you put a replacement injector in, it may have a hump in a different spot, and boy, you talk about leading you down the wrong path.
Wow, yeah.
You got an injector pattern, you're so focused on where that pintle hump is, and you see one a lot lower or a lot higher, you're like, oh, that's my problem. No, it's a different injector.
Technical people like you might get stumped by that.
Exactly.
I probably would never look at it.
You're totally right on that. You're totally right. All right, so this is the bad injector, and you see a very, very pronounced pintle hump. Now let's go back and look at my case study now. We see that same thing, don't we?
Yep.
This is off of a Ford, and right in that area I have a very pronounced pintle hump, and that was the good injectors, the other 6. Now one of the things you mentioned you wanted to do, which I did do on this car, is I did a injector balance test to back it up. I didn't like the injector pattern. I had a misfire, same as you. Is it spark, fuel, compression? I don't know, right? So I did a balance test, and this is tough to read here, but it says injector balance test showed 22 psi drop on number 5, which is my bad injector, and a 28 psi drop on the other 2 known good cylinders I tested. So that's a 6 psi difference in flow. That injector was not flowing the same rate. This is your car. I believe this is where we are. This is why the test light aided holding it open longer with an injector that's not flowing right. It allowed it to stay open longer and take care of the misfire. So if you would have had the opportunity to do a balance test, you would have seen the same results. You would have had a flow problem. I absolutely am confident of that.
It looks the same.
So, and then let's see where we are. Okay,
there's the one. Oh, wait, I need my test light again. Beep.
So this is the only point, and he's already admitted to the. I think
that was wrong.
Yeah, this particular point in the video. What is that? And what is? I have another capture of the same thing. These are really starting to get to the last ones. Okay, I'll come back to that. So what is that? That was on one injector, and what is that on the bad injector? And what that is, well, there's 2 different things that would cause that. That's not the pintle hump. Remember, the pintle hump is going to be, here's your pintle hump. You can actually see it on this one. We're zoomed in, so it looks further away. But here is the pintle hump right here.
That little bit right there.
And if you were more zoomed in, that would occur closer over here, and you would see that more pronounced.
Yep.
And I didn't capture it, but
is that my good one or
that's
my
your
bad?
good one.
Okay.
And right before that, you showed the bad one, and you had a real long delayed one, and it was out here like that. That's your pintle hump on that one.
Okay.
It just, you're more zoomed in, so it looks differently. And so what these are is, if you're going to take, and I don't know, I didn't look at the wiring diagram, but there would be two things that would cause that. And you already know it, we already discussed it, but for our viewers, we would have injectors that share a feed, this being my fuel injectors, and then potentially we have ignition coils on the same circuit. Now, I don't know that for sure.
Yeah, but something's on that circuit.
What you're looking at right here is absolutely another circuit that has fired, and you're seeing feedback in that feed. And what it could actually be is another fuel injector. The timing of them are obviously going to be different.
Sure, yeah.
And even if the coils are not on this, I have seen coils do this. In fact, let me just take you there real quick. This is in the same chapter in my book where we're using looking at injector patterns. Let me find it. Right here. I have something similar in the top left picture.
Yeah.
That this is an old Dodge Omni.
Nice.
An 88 Omni. Where the heck did I get an 88 Omni from? I don't know, but check it out.
Well, those are the cars that the parents say, go ahead, son, take this to school and work on this one.
Look at your voltage pattern. That is almost identical right there.
I see it.
That is almost identical to what you're looking at in your video that you have.
Yeah. That
is feedback from another circuit. So you talk about a learning curve, not for you. He knows what he's doing. The difference is I have to talk about this all day long, and he just fixes the car and gets the next one. So that's why I can talk a lot more. I just talk a lot more. That's all.
I don't have anything to say really.
But that's what that is for you guys. That is interference from another circuit, and those are things we got to worry about when we're doing troubleshooting. Sometimes, depending on RPM, that line can actually move over, and let's say you have an injector pattern that's nearby. That thing can move into the injector pattern and really throw you off at a higher RPM.
Yeah,
so
sure.
be careful with those spikes. What else did we talk about? Okay, I think that's my last picture. No, it's not. Hold on. That's your zoomed out version. Where is the pintle hump, guys? Can't see it really on this one. It is right in there. If you were at a smaller voltage scale, you're on a 50. If you would have picked a 20, you would see it. And if you would open that up just a little bit more, it'd be more pronounced. It's right in there. That's where your pintle hump is. And that was after you put the new one in. So I think we addressed everything. Was there anything else that you were thinking of? Maybe think of some of your viewers' questions as far as
most people that were talking about it were talking about the test light actually helping with the ground.
But
you know what I mean?
You knew that already. You knew what the test light was doing.
But I mean, like, I didn't honestly know what that double, aggravated double hump in the low current picture, what does that mean? You know what I mean? Is it actually sticking? You know what I mean? You think that's a injector that's sticking? Because a lot of people were maybe even saying, I mean, a lot of it was just people talking back and forth, but did you have windings inside the coil that were shorted together?
Right,
you know what I mean?
All right, well, let's look at that. Let's address the winding question first. And I believe no, it's not a winding problem. Here's why I believe no. Now, I can't really see the height of that. If I can maybe zoom in on that picture for a second. Hold on.
Yeah, but see, I'm on a millivoltage scale with a low amp probe, so that would be.
Oh, is that millivolts?
Yeah, because I'm on a millivoltage scale with a low current amp probe.
That's a 2 amp scale. I got it. I know you're scaling. I understand. You're less than 1 amp is what you're saying there, and some of these are tough to see. Let's get rid of that. I'll tell you where 1 volt is, or 0.1, which would be 1 amp.
Right in the
is
middle.
Going to be it's going to be right there. I believe is your 1 amp line.
Something like what, 7/8 of an amp.
Yeah, so that's your bad injector, and then do I have a good one right in there too? You're at the same amperage level. If you look at that pattern compared to this one, you're at the same amperage pattern. So if we had a winding problem, we're going to see differences in amperage.
Yeah.
I don't believe it's an electrical problem at all with this fuel injector at all.
That makes sense. Because I was trying to figure out, what would cause that, and then someone asked about a sticking injector, and I said, I don't even know what a sticking injector would look like on a graph, if it's even possible. But maybe that's it. Is that possible?
Yeah, well, yeah, because, I mean, if you look, let's go back to my case study. That's exactly what I labeled it. I labeled...
Yeah.
Oh, I just moved that picture. Remind me not to save this file.
Okay.
That's exactly what I labeled this picture as, is a sticking fuel injector.
Okay.
And sticking mechanically. Now, do I know exactly all the ins and outs of...
Yeah, why would it make the hump more aggressive,
Exactly. But what we can say, and keep it simple, is that iron core is responsible for the pintle hump. The movement of the iron core is responsible for the pintle hump. And what it's actually doing, is it holding, and then... all of a sudden moving, so it's a bigger. I don't know.
That's why I brought you here, man.
What we can say is it's not a restricted injector, and it's not from a plugged up screen. There is definitely something mechanical that was going on with that fuel injector, and it matches almost exactly what we're looking at right here on this screen.
Well, that's awesome. I hope that puts it to rest. A lot of guys put it to rest. I think it's been 4 or 5 days.
I didn't even know. See, I commented on his video because I'm trying to get you guys over to his channel. And when I comment over there, some of you will follow me, and I actually pretended to watch it, and I really didn't watch it, and I didn't know what I was missing. I could have been part of this conversation.
Yeah,
the whole
well, I
time.
was waiting for you to chime in because there's a lot of people back and forth. I'm like, oh, just let it go. We'll see if he
I guess I don't
sees
love you
anything.
anymore.
Yeah, whatever.
And he's wearing boots, and I'm wearing my tennis shoes. Is he taller than me
No,
right
but
now?
we'll see on my camera.
Your camera's
I was
off.
shorter. Oh, maybe.
He actually is a little bit taller than me. I
don't know.
And he grows a better beard. This is like, I'm trying to grow one, man. This is it, man. It's like, hey. That's why I got more haters.
Well, now, like when I look down, I can't even see into my pocket anymore. Wake up, it's under my arm.
So stop thumbs down in this guy.
Yeah,
man.
we only got one. There's one guy. Just talk to me.
It's
We're all right. I'm cool.
Haters,
No,
it's okay.
whatever,
It's
I
the
don't care.
beard. It's the beard. He's
the beard.
jealous of the beard.
Whatever.
Yep. So hey, man, thanks for letting me invade your space.
No, it was awesome, man. That was cool because, like I
And-
said, there was a lot of I had some feedback that this is going to address, and even for my own personal, you know what I mean, just to see that you saw it and you were able to go in more detail. You know what I mean?
Yeah,
as
cool.
far, you proved what we were thinking, and with the fuel flow part of it, which is what we were thinking, and it's just good to see that the master over here is. I'm kind of on the same page as him. I think I understand what's going on.
No. Do you think we addressed the flow issue good enough with the test light? The magnetic field was
because I never even saw that. You know what I mean? Like you're seeing that 1 volt maybe. So I'm definitely messing with the voltage in the circuit, and like what you were saying with this hump moving over, just
he says voltage.
Voltage.
That's this Pittsburgh accent. You guys broke me of the voltage. I listen to my older
what's
video.
Wrong with
Nothing.
voltage?
It just sounds funny to me now because it's voltage.
Whatever.
He says voltage.
But,
Sorry, go ahead.
No, I was just saying that that shows that we were maybe the field collapsed a little bit slower, and then as you see the pulse width.
That's our delay right here, man.
Would shorten, you know what I mean? And
Are we clear on that? Why
makes sense.
Why did that pulse width shorten, guys? The pulse width shortened because the injector sprayed longer. So remember, we're issuing with a lean code. We're issuing rich commands already. Compile that with an injector that's now spraying longer, and your O2 is going to go rich.
I wish I would have had my fuel trim data there too.
O2, yep. And that's.
But I mean, I mentioned it because you could watch it change, and I think I did. I don't know if I said it or
you did.
wrote it.
No, you didn't say anything wrong there. You covered that well.
I think I said that whole bank probably.
That is
did
correct. That is
know?
closed loop fuel control, and that's the O2 affecting that. So, the spikes again, I think we're good. The spike lowered because we never really fully collapsed that magnetic field.
Yeah.
So, that's what happened there. And I don't know. I think we covered everything else.
No,
good.
it's cool. That's
Guys,
awesome.
check out his channel. It's James Danner. Again, I'll put a link in here, maybe a little tab in the video in these sections, although a lot of you guys don't see the little click here tab, so I'll make sure I put a description in this video for his channel. You need to check him out, and honestly, guys, we're going to do more stuff together here coming up, so appreciate your time. Hopefully you guys like this, and anxious to hear some of your comments. So,
all right, thanks, brother.
thank you.
Yep.